Okay, this is section 6.2. Function composition. Function composition can look really confusing, but if you remember, function composition is just a fancy word for a two-step function. Then things become a lot easier. So let me give you an example. Let's say I have two functions, f and g. They act on different sets of inputs. So the inputs to f, let's say, are x's, and the inputs to g, let's say, are y's. And in particular, f of x is x squared plus 1, and g of y is a natural log of y. So each of these we could think of them as one-step functions. You can even think that as a two-step function if you want. And if I want to build a two-step function, I might say, first I want to square x and add 1, then take the natural log of the result. So let's do that. We're going to square x and add 1 and take the natural log of the result. And we've created a two-step function. And if I want to write this as the original functions, I notice that this right here is f of x. So I can write this as natural log of f of x. And I notice that natural log of something is g. So that's g of f of x. And this is a composition. You take your original input, goes into your first function, which gives you an intermediary output, which goes into your second function to give you a final output. And the way we write it is either this way with the parentheses, or we put a little circle, and we do the outer function comes first, little circle, then the inner function. So I could ask you, for example, what's g composed with f evaluated at 3? And that just says, okay, do f of 3 and then do g of the result. F of 3 is 3 squared plus 1. And g of the result is natural log. So that's natural log of 10, which is something close to 3. If I were to actually calculate it out, I'd get something probably not close to 3, something a little less than 3. Let me just look it up real quick. 2.3, approximately 2.3. And that's basically how a composition works. You just think of it as a two-step function. So there are a couple things to keep in mind with compositions. The first is, do compositions work both ways? By which I mean, can I do g composed with f or f composed with g? Like, are those both allowed? And this is a point of contention between teachers of mathematics. My feeling is no, you should not do both, because as soon as you pick a function, you're giving it a certain value, a certain set of inputs, a certain domain. And there's no guarantee that the inputs that go to f are the same inputs that would go to g. Other teachers of mathematics will say, well, if you just think of inputs as being numbers, then it shouldn't matter. So in this class, you're going to see you can do a composition in either way, but you're not going to get the same answer. So let's look at g composed with f. based on this function, we already know that is a natural log of x squared plus 1. What about f composed with g? I'm going to insist, since I'm making this video, that I'm using the inputs associated with g, which are y's and not x's. That's g of y and then f of the result. G of y is a natural log of y, and then f squares it and adds 1. And you can see these are definitely not the same. For a couple of reasons. First of all, this is first doing natural log, then squaring and adding 1. This is squaring and adding 1 and then doing the natural log. The other reason that I find important is this function takes a certain set of inputs, which are not necessarily the same as the inputs that go into this function. Speaking of inputs and outputs, let's think about domain and range. Of propositions. And sometimes we draw them with a diagram like this. I'm going to come up with a function that I think will help illustrate both how to think about domain and range, and also to think about the order in which you compose. So let's say that I want to cook dinner and my ultimate goal is to make a soup. And to make a soup, I need vegetables. Is that right? Let's see. Yeah. And to have vegetables, I need to plant some seeds. So my first function I can think of as growing the vegetables. And my second function I can think of as cooking the vegetables. Growing vegetables from seeds. Let's be really clear, from seeds. So my domain over here are seeds. I might have, well, if I want to make a pumpkin soup, maybe I'm going to grow pumpkin seeds. Or if I want carrot soup, maybe I'm going to start with carrot seeds. Well, these are all going to be seeds. The vegetables I get, they might be pumpkin, it might be carrots. What's some other things that might be soup? Well, if I'm making soup, maybe I want some bacon in my soup, right? So these could be not just vegetables, but ingredients. I could think about having bacon in my soup, but there's no seed that grows into a bacon plant. So my pumpkin seeds give me pumpkins. My carrot seeds give me carrots, but there's nothing that's going to give me bacon. And maybe I'll grow some other type of seeds as well. Maybe I'll grow sunflowers. And those will give me sunflowers, but I'm not going to put any sunflowers in my soup. So if the question is, if I come all the way back to the seeds, which of these seeds are in the domain of my soup function, right? So growing the seeds, growing the vegetables from seeds, cooking the vegetables, and maybe that combined function is making soup. So the domain of my soup function, soup, let's say soup composed with growing function, is the seeds that grow into vegetables. Pumpkin seeds and carrot seeds grow into vegetables, which then I cook into soup. The sunflower seeds, they don't get to be part of my soup. So even though they're in the domain of my growing function, they're not in the domain of my composed function. And the bacon is going to go in my soup. But even though it's an ingredient, it didn't grow from a seed. So it's not in the domain of my soup composed with growing function. So the domain of a composed function, let's do G composed with F of X, are the X values in the domain of F that produce F of X values are in the domain of G. I have 3 X values in the domain of my F function, but only 2 of them give me outputs that are in the domain of my G function. Pumpkin seeds and carrot seeds. I also like this example because it reinforces why you can do a composition one way, but a composition the other way doesn't make sense. If this is my F function and this is my G function, then G composed with F is soup made with vegetables that I've grown. That makes sense. But if I try to do F composed with G of, well, that would have to be Y, right? That would say I start with carrots, cook them, then plant them, and expect them to grow. Right? Starting with something in the domain of my G function and cooking it, that's my first function, G, but then I have to plant it and think that it's going to grow. And carrots don't grow once you cook them. So the order in which you approach a composition of a function really matters. And in this class, there will be times when you're asked to compose a function with one first and then the other first. And you'll do that because that's what we expect you to do in this class. But in the real world, it doesn't actually make a ton of sense. Okay, so let's look at another example. Here's something similar to question 4. So let G of X equal the square root of X plus 3, and let F of Y equal 1 over Y squared plus, nope, so how about Y squared minus 4? Okay, I'll write it again. 1 over Y squared minus 4. And I want to do F composed with G. So if I'm composing F and G, that means I'm first putting the X's in. And I can write that as X goes into G, gives me an intermediate output that I put into F. So I'm going to say, where's my F function? Every time I see an input, I'm going to replace it with G of X. Here's a word of advice: do not simplify. If we think about simplifying, I'm going to use red. I'm going to get 1 over, and the square root and the square cancel. And I get 1 over x minus 1. And if you remember your rational functions, my domain is everything except 1. But if I look at this function and say I have a square root there, I can't put anything that would be less than 0 in that square root. The domain of G is hard bracket -3 up to infinity, because that's what makes this positive. So I can't put numbers smaller than -3 into f composed with G because they would never get through my first function. Simplifying hides that fact, and simplifying would lead me to get the wrong answer for the domain. The domain of G is -3 up to infinity. The domain of f is, let's see, everything. So I get the y squared minus 4. So that would be everything except -2 and 2, because those are the two numbers that would make y squared minus 4 equal to 0. And now I have to think about what are the x values in G that would give me inputs into F. So let me just do it this way. Sometimes this diagram can be very helpful. If this is G and this is F, everything from -3, -2, -1, 0, 1, 2, forever and ever, and also fractions. When I put that through G, I get -3 goes to 0, -2 goes to 1, -1 goes to square root of 2. I'm okay with all of this so far, but look what happens when I put 1 in. 1 goes to 2. 1 plus 3 is 4, square root of 4 is 2. Can I put 0 into F? Yep, I sure can. That's -1/4. That's not a problem. I can put 1 in. That's -1/3. I can put square root of 2 in. That's 1 over square root of 2 minus 4. But if I try to put 2 in, I get 1 over 0, which I can't do. So if I want the domain of F composed with G, I find the x values that go into G that ultimately give me an output in F. And so this number is okay because it goes all the way through. This number is okay because it goes all the way through. This number is okay. 0 would be okay, but 1 is not going to be in my domain of my composed function because it can't go all the way through. And of course, there's more numbers that can go into F. This, for example, I could put -5 into F. That's not a problem. But I can't get -5 from G. So that could go through, but it didn't come from anywhere. So that can't be in my domain either. So in this example, 1 is like the sunflower seeds. It can go through my first function, but it can't go through my second function. And -5 is like the bacon. It can go through my second function, but it didn't come from my first function. So my domain here is going to be the x values that can go into G and end up giving me an output. So I have to stop at 1 because 1 doesn't go all the way through. And then I can keep going out towards infinity. And this is the domain. All right, last piece. Two more pieces. Okay, composition from graphs. This is really nice. I really like composition from graphs. So if this is x and that's f of x, and let's just have a function that looks like this. Let's say that's my function. And this is an input into g, so y and g of y. And let's say it just looks like, keep it simple and make it look like this. So I'll put some units. 1, 2, 3, 4. 1, 2, 3, 4. Let's say that's the top there. And 1, 2, 3, 4. 1, 2, 3, 4. Okay. So I can look at g of f of x, which is f of x, and then g of that. So if I do g of f of 2, let's pick a different one. I don't like this function. I'm going to change it to this. 1, 2, 3, 4. 1, 2, 3, 4. Y and g of y. Okay, but I'm still going to do g of f of 2. So that means I start with 2 here and I trace it up and I get 4 as my intermediate output. So now I come down over here to 4, which is my intermediate output, and I get 0. And if I want g composed with f of, let's just do of 1. That says I start here at 1. I find the corresponding point, which is 2. I take that down to here, and I go up, and I get 2. So to do composition from graphs, you just start on the x-axis of your first graph, grab an intermediate output, bring that down to the horizontal axis of your next graph, and then find the ultimate output. All right, last thing is deconstructing compositions. So if I told you that I have a function h of x equals natural log of x squared plus 1, and I want to write it as g composed with f of x, now I can find f of x and I can find g of y. So my inner function could be something like x squared plus 1, and my outer function could be something like natural log of y. Or maybe I just want my inner function to be x squared, and then my outer function would be natural log of y plus 1. Those are both okay. What we won't accept is f of x equals x and g of y equals natural log of y squared plus 1. We don't want you to just rewrite the whole function as your second step and have your first function just be f of x equals x. So pulling apart a function into two different pieces that could have been put together in a composition to match that final function. All right, that is the end of the video.